Hey everyone, so I'm going to do the review sheet for your replacement test, which is this week. So the first question says, what is the difference when 3g squared minus 4g plus 2 is subtracted from 7g squared plus 5g minus 1? Now the one thing you need to keep in mind here is the word from, because when you see the word from, you have to switch them. So meaning that 7g squared plus 5g minus 1 is going to go first, and then we're going to subtract 3g squared minus 4g plus 2. Now we're subtracting the whole entire thing, so you do need parentheses around that. What we're going to do is we're going to distribute that negative. So I'm going to keep the first one the same, the 7g squared plus 5g minus 1, but in the next one I'm going to have a negative 3g squared plus a 4g and minus 2. So now I have distributed the negative, so all I have to do is combine my like terms. This becomes a negative 3, this becomes a positive 9g, and this becomes a 4g squared. So my answer is choice B. The next question says, what is the cube root of? What we can do here is actually break up the cube root into each piece. So I'm going to distribute it over the numerator and over the denominator. Now, the cube root of 27 is 3. What you do for this little section here is you need to remember power over root. So really what we're doing is we have x to the 15th divided by 3. And the same thing for the bottom. It's really 9 divided by 3 because the power is 9 and the root is 3. So remember power over root. That'll become 3x to the 5th and then y to the 3rd. Sorry, I should have made this a y. But that's your final answer. 3x to the 5th over y to the 3rd. Okay, so the next one says factor completely, so you're going to have to think of all the types of factoring that you've learned. The first one is dots, and the reason why it's dots is because it has perfect squares and subtraction, so I can factor this into 3x and 3x and plus 10y and minus 10y, and that's my answer here. Okay, so the next one I'm going to pull out a GCF first, which is 3. So I'm going to pull out the 3 and end up with x squared minus x minus 6. And now I'm going to institute AM. So I'm going to have an AM method here. So I'm going to have the 3 stay, and I'm going to do x and x. The factors of negative 6 that I add to negative 1 be different signs because I have a negative here. And it'll be negative 3, positive 2. And that's my final answer. For the next one, I see subtraction, but I also see cubes. So this is perfect cubes. And if you remember with perfect cubes, you have a parenthesis for a binomial and a parenthesis for a trinomial. And we write the word SOAP. To get the first piece of this, you're going to take the cube root of 64a cubed to get 4a minus cube root of this is just z. So if you notice, S stands for same. So this was subtraction, so it keeps as subtraction. Opposite means it'll be addition, and always positive is addition. So now I'm going to square this to get this piece here. So I end up getting 16a squared. Now I'm also going to square the last piece, which is this piece here, to get this piece. So that ends up getting me z squared. And then to get my middle piece, what I do is I multiply this times this to get 4az. And this is my final answer. Okay, for the next question it says divide. Now first off, what I realize is that I'm dividing by something that's linear, meaning that it's just x to the first, so I can actually use synthetic division. And I do that by setting the bottom equal to 0 and getting 2. That's what goes inside my box. Now what I notice here with the synthetic division is that I'm missing the squared. You cannot be missing anything when you do synthetic division. Every single power has to be represented. So what we do is we put in a 0 as a placeholder. So now I'm going to put my coefficients. So 3, 0, 15, and negative 35. I'm going to drop down to 3. 2 times 3 is 6. Add the 0 and the 6 to get 6. Multiply 2 times 6 to get 12. Add those to get 27. And 3 times 27, 2 times 27 is going to get me 54. And when I do 54 and negative 35, I end up getting 19. So my final answer is 3x squared. It's squared because we go down by 1 power, plus 6x, plus 27, and then plus 19 over x minus 2. You will take that remainder and divide it by the thing that you're dividing by, your divisor. So for the next question, I'm going to simplify completely, where I is an imaginary unit. The first thing I'm going to take care of is this piece right here. What I can do is actually just distribute the cubed, and the reason why I can do that is because it's just multiplication on the inside. For this piece though, I'm going to have to write it out twice and actually do the box method. Okay, on this left piece, I want to make I cubed a negative I, because I cubed is negative I if you type that into your calculator. That'll get this to be negative z cubed I. So that's the left side. Now the right side I'm going to have to do box method on. So I have z, 3i, z, and 3i. This becomes z squared, 3zi, 3zi goes here, and 9i squared goes there. Okay, so now I'm going to combine what's inside of the box. So I end up getting z squared. These will combine to be 6zi plus 9i squared. Now the I squared is really a negative 1, so that becomes z squared plus 6zi minus 9. Okay, now this negative z cubed I is outside by multiplication. So what I'm going to do now is actually just distribute that into each piece. So I end up getting negative z to the 5th I, and minus 6z to the 4th I squared, minus 9, actually it become a plus because it's negative negative, z cubed I. Alright, so now I'm going to reduce this I squared and make it a negative 1. So it actually ends up becoming negative z to the 5th I plus, because that's a negative and a negative, plus 6z to the 4th plus 9z cubed I. For the next question it says, g of x is graphed on the grid below. So on the grid below is g of x, this like zigzaggy graph. So that is g of x. So it says graph the function, this function here, k of x, with all these different translations. So basically, if you notice, g is in there. So basically, k of x comes from g of x. And if you notice part B, it says describe the graph of k of x as a series of transformations on the graph of g. Well, the first thing I notice is that there's a negative here. That's a reflection over the x-axis. Then I also notice there's a plus 1 on the inside. That is left 1. And then the negative on the outside is down 2. So what I'm going to do to each point is I'm going to reflect it over the x, and then I'm going to go left 1, down 2. So I'm going to go over the x for this one. So this point will move here. I'm going to go left 1, down 2. So I'm right there. So over the x, left 1, down 2. So right here. I'm going to do that to each point. So this point here is going to go over the x, and I'm going to go left 1, down 2. So right here. Connect. The next point, I'm going to count 1, 2, 3. 1, 2, 3. It's going to go left 1 and down 2. So right there. And I'm going to do the same thing with this one. So I'm going to count 1, 2, 3. 1, 2, 3. Left 1, down 2. So right here. And then if you notice, I cannot reflect this point because I'm on the axes. So I'm just going to go left 1 and then down 2. So right here. So left 1, down 2, right there. And I connect this one, and that one. And there is my sketch of k of x. The next question says, solve for v and express your answer in simplest radical form. There are two ways to do this problem. One way is with completing the square. So I'm going to do that first. Complete the square. And then I'm going to also do it with the quadratic formula. It does not matter which way you guys pick, you just got to pick one to get the answer. So I'm going to do completing the square first. The first thing you do is add the c term over. That'll cancel out. You get v squared plus 6v, put a plus blank, equals 59 plus another blank. what I'm going to do now is take b, which is 6, divide that by 2 and square it. That'll get me 3 squared, which is 9. So that 9 will go here and here. That'll allow me to do AM method over here, getting me x plus 3 and x plus 3, because factors of 9 that add to 6 are 3 and 3. And that's going to equal 68. 59 plus 9 is 68. Now I'm going to rewrite this as x plus 3 all squared equals 68. And I'm going to solve for x by square rooting. This will cancel to get x plus 3. And I'll have two answers, plus or minus the square root of 68. Now it says simplest radical form, so I'm going to figure out the perfect square inside of 68. And that number is 4 and 17. You can do that by going to y equals and doing 68 divided by x and looking at your table, and you'll end up seeing that that's what it breaks up into. So this will be plus or minus 2 radical 17. The 4 becomes the 2. I'm going to subtract 3, and I end up getting x equals negative 3 plus or minus 2 radical 17. Now you can also do this problem with the quadratic formula. Like I said, it does not matter which way you approach it. If you're going to do the quadratic formula, though, you will have to write it down from your reference sheet. So this is your quadratic formula, plus or minus the square root of b squared minus 4ac all over 2a. To do this, you need a, b, and c. A is 1 in this case because that's the number from the v squared. B is 6, and c is negative 59. So x equals negative 6 plus or minus the square root of b squared, which is 6 squared, minus 4. A is 1, and c is negative 59. Okay, so I'm going to put this all over that, and then 2 times 1. So I have x equals negative 6 all over 2. I'm going to put that whole inside of the square root in my calculator to end up getting 272. Now, just like I did before, I would go into my calculator and put 272 into my y equals, doing 272 divided by x, and that will allow me to look at my table, and then I can see that the perfect square that goes into that is 16 and 17. Remember, you want the highest perfect square. So then I get negative 6 plus or minus 16 becomes 4. It's be 4 radical 17 over 2. Now you will reduce 2 divided by 6 is negative 3, and 4 divided by 2 is 2. So this is your final answer. And actually, I should not write x, I should write v equals. So those are two ways to do this problem. So also over here, I changed all my v's to x's, so I'm going to change those back to v's. Okay, moving on. So this says solve the inequality. Now this is actually the directions for question 9. This should just say solve. Okay, so to solve a radical equation, what you do is you just subtract 1, isolating the radical. So first step is to always isolate the radical. Okay, and then you're going to square both sides. On the left side, it's going to cross off the radical, and then 12x plus 1 is going to stay there. And then on the right side, you have to do the box method because it's a binomial in the parentheses. So you end up getting 9x squared minus 3x plus 1 if you do the box method. And these will combine to get you 9x squared minus 6x plus 1. And that's equal to 12x plus 1. So I'm going to solve for x by making x squared positive and equal to 0. So I'm going to bring negative 12x over and subtracting the 1. What's nice about this is that the 1's will cancel on either side, and you'll get 0 equals 9x squared minus 18x. So I'm going to factor by using GCF. The GCF that comes out is 9x, and I am left with x minus 2. This will split, give me 9x equals 0, and x minus 2 equals 0. I'm going to solve for x by dividing by 9, and 0 divided by anything is just 0, and adding 2. And x equals 2. What you do have to do for quadratic, for radical equations is you have to check for extraneous solutions. So if I rewrite my original, 12x plus 1 equals 3x, I'm going to plug in 0, so it'll be 12 times 0 plus 1 equals 3 times 0. That'll be the square root of 1 plus 1 equals 0, and that's 1 plus 1 equals 0, and we know that 2 does not equal 0, so this is going to be rejected. It's extraneous. I'm going to check 2 as well, so I'm going to plug in 2 to my original. That'll give me 6 on the right. 12 times 2 is 24, plus 1 plus 1. That's the square root of 25 plus 1. Square root of 25 is 5. 5 plus 1 is 6. So this is an answer. For the next question, it says solve algebraically for all values of x. I see an inequality, so I know that I'm going to need a number line. Okay, and I know I'm going to have 2 answers on here. The reason why I have 2 is because it's squared. Now I notice I have a squared, so I'm going to set it equal to 0. I'm also going to rewrite this in standard form, so minus 11x plus 12 is less than or equal to 0. To solve this, I'm going to use the glasses method, so 2 times 12 is 24. Factors of 24 that add to 11 are 3 and 8. So I'm going to put the 8 next to the 2, and I'm going to make it a negative 8 because I want to add to a negative 11. It'll be a minus 3x and then plus 12. So now I'm going to factor by grouping by splitting this down the middle. I'm going to pull out a 2x and be left with x minus 4. I also want x minus 4 over here, so I'm going to pull out a negative 3. So I'll have x minus 4 here. So now that I notice I have a binomial GCF, I'm going to pull that out and be left with 2x minus 3 and x minus 4. So I'm going to get 2 answers here. X equals 4. In order to solve the next one, you're going to have to set it equal to 0 and actually add 3 and get 2x equals 3 and then divide by 2. You get x equals 1.5. So that's going to go on my number line. So I have 1.5 and 4 going on my number line. They will have closed circles because the original inequality is equal to, if you notice that. I'm going to now test points to see where I shade. So if I pick points to test, I probably would pick numbers inside of here, here, and here. So like 0, maybe 2, and 5. When you test the values, it ends up working out in the center, in the middle. So this is an AND case. The way we're going to write this is 1.5 is less than or equal to x, which is less than or equal to 4. When you shade in the middle, it is always an AND case, and you always use less than. For the next question, it says the accompanying table illustrates the number of movie theaters showing a popular film and the film's weekly gross earnings in millions of dollars. So you have X and Y. So this already, I know that I have L1 and L2. It says explain how you would determine if this set of data has a strong linear relationship. So you would explain that I would find the correlation coefficient of the data. Now, what this does for you, correlation coefficient of a linear regression. Okay, so if the correlation coefficient is close to 1, then we know we have a strong correlation of the line to the scatter plot. So that means that we might have a scatter plot that's really close in a straight line, like the dots would go really close to a line. So I would find the correlation coefficient of a linear regression if it is close to 1 or negative 1. It can be either or, as long as it's close to a 1. Then the correlation is strong. Now, for this specific data, you would type in this into L1, because that's the X, and this into L2. You would go to Stat, Calc, Lin, Reg, and press Enter. In order to see your R value, you need to make sure your diagnostics is on. If it's not on, go to Mode and turn it on, or go to second 0 and turn it on. And for this specific data, I got 0.98. So there's a very strong positive linear relationship between the scatter plot and the regression line. Okay, I hope this video helped. Come to help if you need any more clarification, and good luck.